Welcome to episode 3 of Refactoring with Bob. I'm your host, Bob, and I know what you're thinking. It's that same shirt. He has recorded all 3 of the first episodes on the first day, and he's just pretending that he did them on separate days. Well, let's get started. So for today's episode, I thought it would be fun if we actually, instead of just refactoring existing code, if we write some code and then refactor the code that we just wrote. And I thought it would be fun to do a code challenge to do that. And so I'm going to take this code challenge and I'm going to try to write it in sort of a very naive way. And I'm going to talk through what I'm thinking and what I'm doing. And it's going to be kind of like, I'm going to write kind of developer 101 type of code, which is totally fine because that's exactly the code that I wrote when I first got started. And then we're going to kind of walk through it and combine some things, clean it up, and just make a shorter, more concise version of the code. So the challenge itself is to simulate a broken keyboard where every time someone presses the A key, it toggles the caps lock key instead of actually printing or whatever an A. And so our function is going to accept a string argument as called input. It's going to return a string, and in that return string, anytime there's an A, either lowercase or capital A, it will toggle a caps lock. And the caps lock by default is turned off at the start of every function. I've written a little bit of kind of just boilerplate test code here so we know whether or not our solution actually works. So let's get started. All right, so let's get started by looking at these requirements. I'm going to break them down one at a time and do sort of the simplest stuff and just keep building complexity, the way you might when you first start out. And really, that's the way I still do it. I'll just be a little more naive about how I do it this time. So first of all, the first requirement is basically accept a string and return a string. So I'm going to need an output of some kind. And I'm just going to set this to nothing, to an empty string right now, and then I'm going to return output. Because I can't return input, I can't modify input. I'm going to need a new string to return. Okay, I know I'm going to need to track the state of the caps lock key. I could do that with an enum, but caps lock key is either on or it's off, and that's just a binary choice. I'm just going to use a boolean. It's either true or false. If it's true, then the caps lock key is on. If it's false, then it's not. So we'll just call this is caps on. By default, it's false. So there, boom, got another requirement done. Easy. So now, in order to do the whole caps lock key thing and figure out what the letters are going to be, I know I'm going to have to loop through all of the characters in the string. Easiest way to do that is with the for each, and that's totally fine in this case. So for each character in input, C is arguably a bad name, but this is a simple code challenge, so I'm going to let it slide. Okay, so the first thing I'm going to do, I'm thinking through what I have to do. I need to track the state of the caps lock key. So if caps lock key is on, and if they're pressing an A of some kind, either lowercase or uppercase, then I just need to toggle it off, right? Whoops. Double equals. And sort of the naive approach would be otherwise, if it's off, then I need to toggle it, I need to toggle it back on, right? Some of you might be eyeing this code a little sideways, but we'll get to it. So there, in theory, I've got that done. Caps lock key toggles on and off depending on whether or not you press the button. So next, I need to potentially change the outputted character depending on whether or not the caps lock key is on. So if is caps on, if it's an uppercase letter, well, then I need to output a lowercase letter. If it's a lowercase letter, then I need to output an uppercase letter. There's still the question of if it's like a number, which is neither upper nor lower. I guess I can just check both cases. If it's not lower, and it's not upper, well, then it's, you know, something that doesn't have case, and so we'll just output it exactly as it is. All right, I think we're getting there. So if the caps lock key is not on, then we just return the number, the letter, character, whatever, exactly as it is. Output is plus equals C. There's actually kind of a hidden requirement that we're missing so far, in that if you press an A, we should not return an A at all. There should never be an A in the string, because that's not actually pressing A, it's toggling the caps lock key. And so we need to track if they've pressed A. Sort of the naive way to do that is, did they press A? And we'll say no. Most of the time they didn't, but in these cases, there's 2 branches where they do. Ugh, test C, you're killing me. So yeah, if they press A here, or they press A here, then yeah, they did press A. And then we only output stuff if they did not press A. So we'll just wrap this whole thing in a big old if. There we go. There, I think we've done it. I'm going to run this and see. So because it hit a breakpoint here, I'm using debug.assert, and so this is telling me this was not correct. It says visit labum, and the expected is visit labum with a lowercase b. I don't know if that's actually coming through on the screen capture, actually, now that I think about it. If I go to immediate window, I can look at result, and then if I look at expected, you can see that it's expecting a lowercase b and it's getting a capital B. Now what could possibly be happening there? If I think through this, in that example case, it's ALABAMA. So it hits an A, it sets the caps lock key to on, and then, so the first time the caps lock key will be off, so it skips this branch. If it's off, it will toggle it on. Now it hits another A, so now the caps lock key is on. It's going to see that it's an A, it's going to toggle it off, and then we're going to hit this and say, oh, if it's off, well, it will be off because we just changed that. So this is a bug. We're actually, this bug means we will never be able to actually toggle this on. So instead of these being 2 separate cases, we actually need to make this an else if. Let's try that and see if that succeeds. Okay, I don't think you can see the other window because of how I'm capturing things, but basically it ran, it was successful. So this is technically correct at this point. Good job, team. And let's call it a day. All right, so let's look at how we could start cleaning this up, because this is like really long, and we have a lot of cases where we kind of like an if this, and then else. Like really, this is an else down here. This shouldn't be a separate if, but let's go through this sort of more intentionally. So the first thing that always stands out to me, you know me, I hate duplicated code, and we have some logic here that's, you know, if it's an A, if it's an A. This is a tiny, tiny piece of code, but I still feel like it could be abstracted. Plus, in every case where this is true, we're setting this value to true, so effectively, did they press A is just the result of this comparison. And so we can just do this instead. And because we know that this is true, we don't need to set it to true here. We just need to set it in one place instead of 2. So, did they press A? Did they press A? Okay, so we've moved did they press A out here. Now I noticed anytime you have an if with just like a nested if directly underneath of it, and it doesn't have any other stuff in here, there's nothing going on here. Really, we just have if this branch, we can take this out and just make it an and. We can just and that on there. And so if that, we can do it that way. All right? Whoops. Don't delete all of it. Oh man, terrible. Okay. Just get rid of the branches, not the content of the branch. There we go. That's better. So again, I'm going to move this logic up into the outer condition. Get rid of that stuff. All right. Now here's another little thing that I don't even have to understand what these branches are doing, but I can see a pattern. I see an if condition and this condition, if some other condition and this condition. Because these both have this condition as part of an and, I can actually strip it out and put it around the whole thing, and it will effectively do the same thing. So I get rid of it from there, I get rid of it from here, and I just make the whole thing. This is effectively the same code. Now the interesting thing about this is now I have, did they press A? Is the caps lock on? Set it to false. Is the caps lock off? Set it to true. Well, I immediately recognize that as I'm just toggling. If it's true, make it false. If it's false, make it true. The simple way to write that is caps on equals not is caps on. That's a lot simpler. So, next I wanted to look at this. I've got these 3 if statements in a row here. If it's upper, we lowercase it. If it's lower, we uppercase it. If it's neither, we just output it as it is. Well, what I could do is combine all of these into a single statement, and then I don't need this extra logic. So if it's upper, we handle that case. Otherwise, if it's lower, we handle that case. And then we have this sort of remaining nebulous state where it's neither upper nor lower. I can just do an else because this is all part of the same condition, same set of branches. And this is sort of more accurate. This is probably the most correct way to do this. But one thing I know about char2 lower and char2 upper is that they just don't do anything if the character can't be lowered or uppercased. And so in that sense, I don't actually have to handle this case. All I really need to do is basically, if it's upper, lowercase it. Otherwise, just try to uppercase it. And this simplifies things quite a bit. Technically, it's sort of less correct in that we're uppercasing numbers and stuff, and those can't be uppercased, but I think it also makes the code smaller, and I like small code. So the way I had it before is definitely more explicit and more correct, and if you prefer that, that's fine. I'm going to leave it like this just because it's smaller. In fact, when I look at this, if you have if condition, and then I basically have the exact same code, all I'm doing is changing what I'm doing here. If you really want to, this could be rewritten as a conditional operator. So if it's upper, then we would do to lower, otherwise to upper. So that whole 3-pronged if statement just becomes a single output. So here we have if caps lock is on, if caps lock is not on. Well, obviously that was kind of dumb, but obviously that's just an else statement. So if it's this, else that. All right, so now I'm looking at this. I have this if they did this thing, if they did not do this thing. So I have an if true, and then I have an if false. Like always, anytime you have that pattern, you can actually replace this with an else. And then when I look at this, I see I have an else statement that has an if else as well, and just has these branches. I can actually flatten this, so I can do an else if else here instead, and this will produce the equivalent code. And so basically I handle the 3 possible cases. Either they pressed A, in which case the only thing I do is toggle the caps lock key, or if the caps lock key is on, I output something and change the output, or the caps lock key is not on, but they didn't press A, I just output the thing exactly as is. Okay, so with all those changes, I'm going to test it and see if it still actually produces the right output. And again, I think because of the way I captured this, you probably couldn't see the output window, but it ran, it succeeded, it never hit a breakpoint, so that means that this debug.assert was true for all of these cases. Everything is good, so we have a functional challenge. We've succeeded. Go team. There's one last change that I am going to suggest that you consider. I'm not going to say you should do this. And the reason I'm not going to say this is because it's a performance update that may or may not make an improvement. So anytime you're thinking of doing something for performance reasons, you should benchmark and see whether or not your performance actually improves or gets worse. And so in this case, what I'm doing is I'm creating a string, an empty string, And then for each iteration, well, not each, but each iteration that's not caps lock toggle, I am adding to that string. Now, the way that C# concatenates strings is it will take, whatever string you have here, the string you have here, and it will allocate a new string that's long enough to hold both of them, and then copy all the bits into the new string. We're doing that for every single character. We're allocating a new string and doing a copy. So for the first letter, allocate a string, copy. Second letter, allocate a string, copy. Allocate a string, copy. If you're doing this with very long strings, or even if you're calling this process method in a tight loop with short strings, it might actually have an effect. And so if you find that you're putting a bunch of pressure on the garbage collector or whatever, or you're eating a ton of memory, it might be worth changing output from a string to a string builder. And the plus equals now becomes an append. And then we're not returning the string builder directly. We still need to return a string, so we'll just call toString on this. That's a little bit better. So what it's going to do is string builder is going to allocate sort of a buffer, just an array of bytes. And as you append stuff, it will just put it into that array until it runs out of space, and then it will allocate a new buffer. I think it'll be twice as big, sort of like a list does, and then it will copy everything into the new buffer and then continue appending onto this. And so we can help string builder out by providing the length of the buffer to allocate. So we know that our output will never be longer than our input, because the only thing we can't add to the output, but we can remove, because every time we press A, we don't include that character. And so if we allocate a new string builder, at the length of our input, we know that string builder will have a large enough buffer that it will never have to recreate the buffer. And so we create this string builder, we append to it, and we return it that it's one allocation instead of allocating every single character. Now, again, you absolutely should benchmark this change and see if it actually improves things, because I have been surprised where the overhead of creating a new string builder was actually greater than the overhead of just allocating the new strings. Sometimes, concatenating strings can be a very efficient thing. So don't assume that a string builder is necessarily going to be better. But if you're doing very large strings or a large number of strings in a tight loop, consider a string builder. And if you are doing this in a tight loop, consider reusing a string builder instead of creating a new one every time. There's a bunch of things you could do, but don't do any of them until performance is actually an issue. And when you do them, make sure that your changes actually have the effect you expect them to have. So that's the end of my rant, and I think that's the end of this code challenge. So thanks for joining me.